Thanks. Good morning, everyone. Yeah, I want to talk about the best programmer I know. The reason I want to talk about this kicked off on the Twitters a few years ago, was someone was saying, that kind of gatekeeping that people do. They're going, you can't really become a proper software engineer unless you have a degree, ideally a degree in programming. So I kind of chirped back, because sometimes I reply to people on the internet. And I replied, I said, well, actually, the best programmer I know doesn't have a degree. And the other best programmer I know does have a degree. He has a first-class honours degree from Imperial College in London, which is one of the kind of great computing universities.
Hey everyone, welcome back, and let's write some more neat code.
So it's not an indicator at all. And then we got into, well, it depends what you mean by best programmer. And so I kind of did a stream of consciousness thread thing on the internet about what I thought made this particular person a great programmer. And then I did nothing, because I'm really bad at following up on things. So I've finally now sort of turned it into this. And okay, so the best programmer I know happens to be male. That doesn't matter, right? Because it's not about him, okay? The things going to talk about this morning I've seen in many, many different programmers. I've been computeringing for about 30-something years now, so I've worked with lots of really lovely programmers. The most important person to think about when I'm describing my buddy is you, okay? Because everything I'm going to talk about this morning, everything is learnable. Everything is behaviors, is choices you can make. So my challenge is this: if you're new to this, you're relatively new to this whole computering thing, here are maybe some things that you might find useful, you might want to move towards. For those of you who've been around for a while, Some of this might challenge you. Some of this might kind of, wait a minute, I don't agree with that thing. And I'm very, very happy for you not to agree with this, right? There is no absolute truth in this. These are my opinions. If you don't like them, I have others, okay? So let's start. This is a talk in 3 parts. It's deliberately a talk in 3 parts because I want to get a lot of stuff across to you, and if I don't arrange it into chunks, it's just a big laundry list of things, okay? So let's start then. The first thing this person does is he gets the job done. Which sounds really obvious, right? But we're not very good at getting the job done. So how does he get the job done? He just starts. I have a real problem with just starting. I have always struggled with just starting, okay? So what I do is I procrastinate. I don't call it procrastinating, I call it research. I call it looking up things. I call it preparing myself. It's procrastinating. I'm 12 years into writing a book. 12 years. I'm embarrassed by that. You should all be going, oh my God, how could it possibly take anyone 12 years? It's easy. Just month after month after month, don't write any more book. And eventually, 12 years in, you haven't written your book, right? So what does he do? He just starts. He has the ability to just start. And the reason I struggle with just starting is I have a massive ego, right? Partly because I'm human and partly because I'm a programmer, okay? We've got big egos, and what that means is when I put code into a computer, I want it to be good code. I'm proud. I call it perfectionism. Perfectionism isn't about wanting to build a perfect thing. It's about having a very fragile ego and not wanting to get wounded. That's what perfection, I know because I'm a perfectionist, right? So what he does, which I just find brilliant, and again, I've spent the last probably 15 or so of my 30-odd years in my career trying to explain to people how this person does stuff, right? I've made a career out of it. He gets really embarrassed. I'm not going to tell you who he is. He finds this amusing that I do this, right? But what he does is this. He goes, I'm just going to start, it's because I know whatever I write now won't be there in 10 minutes. Because what I'm writing right now is a sketch, and I'm going to iterate on that sketch. So what he then does is he just iterates wildly. There is a Smith reference in there for some of you more nerdy 80s fans. Iterate wildly. And so there's this idea. In the US, they have a lot of gridded cities. So the cities are kind of laid out like a grid. And in the morning and in the evening, they set up all the lights so that all of the what they call downtown traffic going into the city has all the green lights, and in the evening, all the cars coming out of the city get the green lights, which means if you're going cross town, then you're going stoplight, 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 okay? It's pretty frustrating to go across town in US cities, in Chicago or New York or somewhere like that. So here's what you can do. You can either sit there in your car, wait for all the lights to go green, because then you can go, or you just go stoplight, 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 which is really dull, but you're making progress. And eventually you get the other side of town. Which one of those is going to get you there? Right? And this is the thing. Rather than waiting until I've learnt Node.js, learnt React, learnt Rust, learnt CQRS, the thing, whatever it is I'm going to try and do, I just iterate through it. And I iterate knowing I'm going to mess it up, and knowing that every time I mess it up, I learned a tiny thing. Okay? So I come out of it the other side, the person who knows the thing now. But I've got no idea what that journey was going to look like until I took it. So just start. The next thing he does, which I really struggled with for a while. I think I'm better at this now, right? But I only think so because I keep catching myself. What he does is he builds a product. We are building a software product, okay? Which sounds really obvious, right? But the whole software craftsmanship movement came out of like the opposite of this, right? I am going to build fantastic code. I have the right to build amazing, great code. I don't care. I mean, write good code, right? Take it seriously, but I don't want your code. I want what your code does. In fact, if you can give me what your code does with no code, you win at code. That's how much code I want. I want no code. If I can get the thing with no code, we're winning, right? So code is just a means then. But now you have this, and I describe this as you're holding two conflicting ideas in your head at the same time, which have been reliably informed by a psychotherapist friend of mine is impossible. Okay, it's impossible to hold two competing ideas. These are the two competing ideas. I will write the best code I can, or at least I'll write the most suitable code for this situation. I'll write the best code I can for this situation. I will have no emotional investment in my code. Oh, I'm going to struggle with that second one. Have you seen this? I had a moment, I've just written, and I know if you've been around code for a bit, you've had that moment where you've had this puzzle, and you've solved the puzzle, and it is elegant. It's just lovely. You've written a lovely bit of code, and you stand back and you go, don't care whatever else happens today, that's a lovely bit of code. Okay? So I showed my buddy. I said, come and look at that. That's a lovely bit of code. Am I right? That's a lovely bit of code. And he looked at it, he went, is it live yet? Is it live yet? I hate you. So how do you resolve this conflict? How do you resolve this not having an emotional attachment to something you're taking seriously? And it turned, I realized after a while of observing us and in this very high-performing team, is this: we were caring about the product. It happened to be a trading system, a trading platform. And the point about a trading platform, traders do not want to use trading software. Traders want to trade. That's what they want to do. Ask traders. What do you want to do? I want to trade. Why do you want to trade? Because I make money. The act of trading is the shortest possible value stream between do a thing, make money. Right? But you're buying and selling money. It's very weird. And so what they don't want is your product. What they don't want is the software. The software gets in the way. And we've had some wonderful talks about like developer experience and user experience over the last couple of days. And it's thinking about a product as something that should just be invisible. It should be fabric. You shouldn't be aware of it. So how do we do that? Well, what we do is we study the domain. We learn about what it is the software is trying to do. Yeah? So if I understand how trading works, I understand how healthcare works, how patient record management works, if I understand how supply chain works, if I understand the pieces, I can start to think differently about how I solve puzzles in that space. Okay? And then we get into I know we were talking yesterday about like the kind of the interplay of things like Wardley maps and domain-driven design and bounded context and all of this kind of stuff. We can only start to do that thinking. We can only start to have those conversations when we study the domain. Okay? And by the domain, I don't mean abstract the world of trading. I mean the people who live there, right? What do traders do? What do trading assistants do? What does compliance do? In a hospital, it's not just doctors and nurses. There's huge teams of people that enable medical care to work at any kind of scale. And this is what your code looks like. Your code has the words in it from the domain. Okay? And watch people. There's a lovely word, ethnography. Ethnography is a fancy word for watch people. Okay? The most powerful bit of user feedback you can get, everyone, please, all of you, spend some time with your users if you possibly can. Sit next to them, watch them using your stuff, and you're listening for this. Yeah. What was that? You just sighed. No, I didn't. People don't notice when they sigh. Right? You did, you sighed. I know why I sighed. Well, why did you sigh? Well, because basically whenever I do this, right, this thing comes up on this screen and I have to just type it in again into this screen and sometimes I get it wrong, I get the surname, I misspell it slightly, or there's a hyphen that goes away, or and you're like, why are you doing that? I don't know, it's just the software, it kind of comes up on this screen, I've got to put it on. I could make that text just appear on that screen. I could have this form populated for you. And the eyes go wide. And they're like, can you? I'm a programmer. I can make a computer do anything. Watch me. Right? But they're never going to ask. ask for that thing. They've got a feature list as long as your arm, and none of it is, I have to keep copying from that screen into that screen. Because they've already internalized that this will never change. This is the way things are. Right? So Bill Buxton, Chief UX chap at Microsoft, he has this lovely, he asks the question, he goes, what is user experience? And then people talk about design and affordances and interaction. He goes, no. User experience is the experience a user has. Oh, yeah. So user experience could be frustration, could be silent resentment, it could be pleasant surprise, right? Whatever that emotional response is to the thing, you caused that. Your software made that happen. You can be writing software, even internal business apps are notoriously bad for this, right? I need to get the work done, not one of my colleagues who I share a canteen with at work is having a miserable, crappy day because of a thing I built. And they're going to continue to have a miserable, crappy day because I know what the next screen does too. So think about your human. Got this, we were at some workshop thing, and I got into, don't get into an argument with Eric Mayer, that's what I learned there, right? But we were coming at this thing from very opposite ends. I was saying, well, always solve for now, and then once you've got enough samples, then you can think about generalizing and think about a library or an API. And he's like, no, I'm not going to try and do a Dutch accent in a room full of Dutch people. That's crazy. He says, no. He says, that's maths, science. Start with a general case, apply it in individual. And we got into this big Barney, and luckily we had someone there who's a mutual friend who kind of helped us see eye to eye. The difference, Event Horizon has this wonderful, says all series of fantasy books, and there's these one sort of little mini arc within this series is about these 3 witches, and one of the witches is called Granny Weatherwax. And Granny Weatherwax has, and Terry Pratchett, some black. An oracle came. He didn't want that, other than the one that presents it. Wait, happens. So okay then, because it's okay another. Java shop, lots of JSON choices. So I said, okay, so let's talk. And then there's these folks that basically interface, and just solve for that. And again, I've done a Wendell Holmes quote. He said, "I wouldn't give a fig for the simplicity this side of complexity, but for the simplicity the other side of complexity, I would give anything." Yeah. Once I've understood the problem and I realize it's just this thing. So okay. Part 2. Choosing.
So the idea is that you want to have a central place. You don't want to create any custom scripts or have any manual processes. You want to have a central view on your backup strategy. So supported services are pretty wide. For example, Amazon EC2, EBS, Amazon S3, RDS, and all database engines are supported. Aurora, DynamoDB, DocumentDB, Amazon Neptune, EFS, FSX, including Lustre and Windows File Server, and probably others. AWS Storage Gateway, such as the Volume Gateway, and more that can come over time, but I'm not necessarily going to update this lecture because, well, it doesn't really matter. The idea is that you get the concept behind AWS Backup, and the most important services are shown on this slide. So it supports cross-region backups. Does that mean that you can have your backups pushed to another region for disaster recovery strategy all in one place? And also supports cross-account backups if you are using multiple accounts in your AWS strategy. So it supports point-in-time recovery for supported services in your AWS strategy. So it supports point-in-time recovery for supported services such as Aurora. It supports on-demand and scheduled backups. There's tag-based backup policies to make sure you only backup maybe resources that have been tagged with production. And you can create backup policies known as backup.
the right tool.
Backup plans, you define the frequency, for example, every 12 hours or weekly or monthly or whatever cron expression you have. The backup window, if you want to transition the backup itself to cold storage, so never or maybe after some days, some weeks, some months, or some years, and the retention period of your backup. So always, or days, weeks, months, and years. So it's quite supportive and comprehensive, and it supports really most services. So it's a really nice addition to the AWS services. So if we have a look at AWS backup, we create a backup plan, as I said, and then you assign specific AWS resources. That are important to you. So here is a list, but it can get bigger. And then once it's done, well, automatically your data is going to be backed up to Amazon S3 in an internal bucket that is specific to AWS backup. And another feature you need to know about for AWS backup is the vault lock. So you enforce a warm write once, read many policy. That means that all your backup that you store in your backup vault cannot be deleted. So the idea is that you know for sure, you can prove it, that thanks to the vault lock policy, you cannot delete your backups. And it provides you an additional layer of defense for your backups against, for example, inadvertent or malicious delete operations, or updates that shorten or alter the retention period. And even the root user itself cannot delete backups when enabled, so it gives you strong guarantees on the safety of your backups. Okay, that's all you need to know for the AWS backup service. I hope you liked it, and I will see you in the next lecture. Okay, so let's practice. practice using AWS backup. So I'm going to type AWS backup into the search bar and open the backup service. So we are going to create our first backup plan. So I'm going to click on create backup plan. And we have three options. Either we start with a template, or we build a new plan, or we define a plan using JSON. So the simplest for us is to start with a template, and we can have different templates. For example, daily 35-day retention, daily, monthly, 1-year retention, and so on. So let's go with daily, monthly, 1-year retention, and I'll call it test plan. Next, we click at backup rules, and you see we can have many backup rules in our backup rules. So we have two. We have daily backups and monthly. So if I click on daily backup, as we can see, there's a role name. The backup vault is wherever the backup is going. So we can use a default one by AWS, or we can create our own new backup vault if we wanted to. The backup frequency, the backup window, so when to start, which is 5 a.m. UTC, start within 8 hours, but we can customize it if you want. Whether or not you want to transition to cold storage, never after some days, weeks, months, or years. And the retention period of your backup, for example, this one is retained for 5 weeks. Then we can also copy these backups to a specific destination, for example, another region, for disaster recovery purposes. So I'm going to save this backup rule. And for monthly, well, we get the similar thing. So it's going into the default backup vault. It's monthly on day 1 of each month, and the rest looks the same. So we actually transition these ones to cold storage after 1 month, and then we retain them for 1 year. Okay, so we have these ready, and then I can just scroll down and click on create plan. So now our test plan is created, and we need to assign resources to it. So I'm going to click on assign resources, and I will just call it test assignment. And so here for IAM role, we're going to use the default role, which is going to create a role for us with the correct permissions, or you can choose your own one, but let's go with default role, easy. And then for resource selection, we have 2 things we can do. Number 1, we can include all resource types, or number 2, we can include specific resource types. For example, if you wanted to just have a DynamoDB table, and then you could select the resource you want on there, you could do this. Or if you wanted to, you can have all tables. So it's one way of doing it. Or if you go with all resource types, usually we'd use this as a combination with tags. And so for tags, you would say, well, if the key environment is equal to the value production, then do a backup. This would be the kind of use cases for backups. But you're free to do anything you want, of course. And then when you're done, you click on assign resources. And so just to make it very, very clear, if I went into EC2 and I were to create an EBS volume, and that volume would have, so for example, 1 gigabyte, and then the key would be environment production, then this would be automatically backed up by my backup plan because it has the correct tags. So if we look at our volume right now and we go into tags, as we can see, it has environment production, which corresponds to the tags that I've set up for my backup plan. Okay, so this is the assignments right here. And we can have multiple assignments as well in here. Okay, and then that's it. The backup plan is going to run automatically, and then the backups are going to appear in my backup vaults. Okay, the jobs are the jobs that are going to be scheduled and happening. So we have backup jobs, restore jobs, and copy jobs if we wanted to. And then we can look at the settings. So the settings is around, do you want to have backup policies, cross-account monitoring, cross-account backups, and so on. But we've seen the basics of how backups work. And so that's it. I wanted to show you all this, okay? That's all you need to know. And I'm going to delete everything. So for that, please make sure to delete your EBS volume, or you could wait a day if you wanted to see if the backups work, obviously. And then when you're done, you take the assignment and you delete it. So type the name of the assignment in here. And then for the daily backup rules, we can delete them or delete directly the backup plan. And for this, just enter the name of the backup plan and press delete. And that's it. We've seen backups. I hope you liked it, and I will see you in the next lecture. So there are 2 use cases when you move to the cloud. For example, you want to start fresh and you want to leverage the cloud directly. In this case, you don't need to do a migration. But if you have on-premises servers and data centers and you want to migrate to the cloud, then you need to plan your migration. And a way to do this is to plan your migration using the AWS Application Discovery Service. So the idea is that you're going to scan your servers and going to gather information about the server utilization data and dependency mapping, which are going to be important for your migrations, so you can understand how to migrate and what to migrate first. So there are two types of migration you can do. One is called the agentless discovery, using a connector, and this gives you information around your virtual machines, your configuration, your performance history, such as the CPU, memory, and disk usage. Or you can run an agent to do an application discovery agent, and this gives you more updates and more information from within your virtual machines. For example, system configuration, performance, processes that are running, and the details of all the network connections between your systems, which is good to get your dependency mapping. Now, all this results data can be viewed within another service called the AWS Migration Hub. So this application discovery service really helps you to map out what you need to move and how they are interconnected. But then you actually need to move. And the simplest way to move from on-premises to AWS is using the AWS to move, need to move. And the simplest way to move from on-premises to AWS is using the AWS Application Migration Service, also called MGN. So this used to be called Cloud Endure Migration, but now it's been replaced, okay? And the idea is that using the AWS Application Migration Service, so MGN, you can do rehosting, also called lift and shift solution, in which you convert your physical, virtual, or other service or the servers on other clouds to run natively on AWS. How does that work? Well, say you have a corporate data center with OS, apps, and databases, and they run on disks. What's going to happen is that you're going to run the application migration service, and then the replication agent that you have to install on your data center is going to perform a continuous replication of your disks so that you have, for example, low-cost EC2 instances and EBS volumes that get this replication of data. Now, the day you're ready to perform a cutover, you can actually move from staging to production and have a bigger EC2 instance of the size you want, as well as EBS volumes that match the performance you need. So the idea is that you replicate data, and then at some point, you do a cut. Cutover. And that is by far the simplest way of doing it. So this supports a as well as reduced cost because, well, you don't need to hire complex engineers to do this. This is done automatically by this service, okay? So that's it. I hope you liked it, and I will see you in the next lecture. So here is a quick summary lecture to describe to you all the ways you can transfer a large amount of data into AWS and which one is going to be the most appropriate based on the constraints you have. So for example, let's say we want to transfer 200 terabytes of data into the cloud internet or establish a site-to-site VPN, which also uses the public internet. And the advantage of this is that it's immediate to set up. We can leverage our connection right away. And if we do a quick computation, what we get is that it will take 200 terabytes converted into gigabytes and then megabytes. Then you have to convert this into megabits, so times 8. Then you divide by the speed you have, so 100 megabits per second. And that gives you about 16 million seconds, which is the equivalent of 185 days, so almost half a year to transfer 200 terabytes of data over a 100 megabits internet connection. So this can take a long time. Obviously, based on the size you have the data, it could be appropriate or not. And in this case, I will never probably transfer 200 terabytes over this internet connection speed. If I want to transfer now over direct connect and say we have provisioned a 1 gigabit per second line, then the first thing is that it's going to be a long one-time setup. So if I'd never had direct connect before, it will take about a month to get this connection established. And then once I have this connection, it will take about, if we do the exact same computation, 10 times faster than my first connection. So it's going to end up being 18.5 days. So a lot quicker, but still quite long. Now, if I use Snowball, how long do I need? Well, first of all, I need to order my snowballs, and then I need to get about 2 to 3 snowballs, and I can order them in parallel, so they will arrive at my facility at the same time. And then it takes about 1 week, all in all, from the snowball to being delivered, to being loaded, to being sent back to AWS and the data being transferred. It'll take about 1 week for the end-to-end transfer. And on top of it, if there was a database that was being transferred through Snowball, it could be combined with DMS to transfer the rest of the data afterwards. So finally, for ongoing replication, so this is like for one-off transfers, for ongoing replications, we could use techniques such as site-to-site VPN, again, because we'll have less data to transfer on an ongoing basis, or use Direct Connect, or use DMS, or use a service like we just saw, like data sync. So all these things would allow us to transfer the data on an ongoing basis, continuously or not, through some more reasonable internet lines, such as a site-to-site VPN or Direct Connect. Okay, Snowball is going to be used more for one-off large transfers, and as you can see, Snowball in this case is really, really helpful into speeding up our first data transfer into AWS. Okay, so this lecture is just about to make you realize which use case is more appropriate and what are to send. I will see you in the next lecture. So now let's talk about VMware Cloud on AWS. So here's some context. When you have an on-premises data center, sometimes you would use the VMware Cloud to manage your own on-premise data center. So you have your vSphere-based environment and your VMs all managed from VMware Cloud. And customers who have their own data center with VMware, they want to extend their data center capacity to also leverage the cloud, and in particular, they want to leverage AWS. But they want to keep on managing everything, their own data center and the cloud, using the VMware Cloud software. So this is the idea behind VMware Cloud on AWS. Thanks to it, you can extend your entire VMware Cloud infrastructure to also be on AWS and run vSphere, vSAN, NSX, and so on, which you don't have to know, but they are VMware sub-services. So once you have this, what are the use cases? Well, the first thing is that now you can extend computing power from data center to the cloud, or storage from the data center to the cloud. And therefore, you can start migrating your VMware-based workloads to AWS. You can also run your production workloads across multiple data centers, and you can choose between private, public, or hybrid cloud environments. And finally, it gives you a disaster recovery strategy, because now you can quickly go to the cloud using the same suite of software that you know. And because that now you are on the AWS cloud, you can actually access the different AWS services and start leveraging them, such as Amazon EC2, Amazon FSx, S3, RDS, Direct Connect, Redshift, and so on. So that's it. It's just a high-level overview that you need to know. I hope you liked it, and I will see you in the next lecture.
Welcome! This video is going to give you a step-by-step roadmap to becoming a back-end software engineer. So not only will this tell you what tech to learn, but it will give you the order in which you should learn it. So if you have no idea where to start, this is going to take you from where you are right now to the end goal of becoming that back-end engineer. Now we're going to start by looking at this mind map I created. Do not fret, this is not the roadmap. You do not need to know everything inside of this map. In fact, you can't even see it. There's so many things on here. But if I zoom in, you'll notice that there's themes of different categories and then a bunch of different technology you might encounter. It might be a good idea to become familiar with these different things, but you don't necessarily have to know every item in this list. Instead, you should pick one item out of each category and become an expert in it. So you start by understanding the landscape and what exists out there, but then you narrow in and you become really good at one of those things. And that's where you're probably going to spend 80% of your time, and then maybe 20% of your time understanding the context of everything, so understanding the different technologies you might encounter. That's my general framework for learning. So what this video is going to do is it's going to give you some example items that you could start to learn with. Although if you substituted one of these items with another item from the same category, it still might work. This is just an example roadmap that I would recommend if you really have no idea where to start. Now the roadmap is actually at the bottom of this mind map. So if you want to get access to this mind map and roadmap, I'll have a link for that down below. And if you want more direct help, me guiding you through this process with one-on-one mentorship, I do have a mentorship program. So if you want to learn more about that, that's basically going to give you that accountability, and it will help you build the skills and the things you need to know for your career so you can be successful as a software developer. So going through this mind map is a great place to start, but if you want that extra help, then check out the mentorship program. So the secret here is to not learn everything, but rather learn a technology from each category. This will give you experience in the end-to-end while also giving you something to compare every other technology against. So if you're really, really good at the Python programming language, you can compare other languages to that language, so you don't have to have as much of a struggle learning new languages. You just think of how it's different than what you already know. That same idea is going to apply to a lot of different tech. So we'll start at the very basics, which is the operating system. You should become pretty comfortable with your operating system, so you should start to learn the commands to use and just be competent in working with different tools on that operating system. Now, I develop on a Mac, but it's often the case, especially within back-end engineering, you're going to be deploying to Linux. So I recommend you learn your primary operating system, Mac, Windows, or Linux, but also make sure you learn Linux. So if you've been wondering if you should do that, yes. The answer is yes, you should learn Linux, learn the basic commands. And if you're on Windows and you want to start to become more familiar with Linux, here's a couple of things you could do. So to start, you can look into WSL, which is going to give you some of the essential Linux capabilities on Windows. Another option is to install a different type of terminal. So if you, for example, download Git, you have the option to include a Git bash program, which will use MinGW. So if that is all foreign language to you, go download Git. That's going to give you a terminal, which will give you some of the essential terminal commands that you would experience on Linux. And then the third option, which is going to give you the most one-to-one experience, is to actually just use a Linux operating system. And you can do this within a virtual machine, or you could, of course, install Linux directly on the hardware, but I would probably just go with a VM and get some experience there. When you deploy something to a backend server, you're going to need to understand these basic commands, because if you need to connect to the server, you're likely going to use SSH, and this is going to be a connection through the terminal. So if you want to be able to work with the computer, you'll need to know how to do that in the terminal. This would include learning the basics of a terminal-based text editor. So next on here, the editor, I recommend generally VS Code, but since you might on occasion be working in a terminal, you might want to learn the basics of something like Vim. But in terms of actually working with code to build applications, your day-to-day editor, I personally use VS Code. If you have a preference here, this is the kind of thing where this roadmap is an example. Feel free to substitute it for another item. I'm just warning you against trying to learn all of the items. I like VS Code because you can develop pretty much anything inside of it, and you don't have to have 5 different IDEs, one for each major language you're working on, for example. That'll help you get better in VS Code. That's the tool you use to develop, so you're going to become more efficient and just a better developer. Even if you're not directly getting better at a programming language, getting better at the tools and the things you use will help you become a better developer as well. So that's the basics. The next thing you should learn is source control or version control. And for this, you're going to want to learn Git, and I recommend using it in the terminal to become familiar with those commands. And then you can host your repositories in GitHub. GitHub is a service where where we can host our code. Git is just a software you can install to help you manage and organize your code, keeping track of any changes you make to that code. You will definitely want to use Git for all of your projects. I recommend to everybody that they put all of their projects in GitHub for organizational sake, as well as showing activity as a developer. Here's all the stuff I've been working on. Even if the code sucks, it's just a matter of showing that you're working on something. And most likely, if you don't put your code up on GitHub, 5 years down the road, you're going to lose that project. You're going to wish you had it. So if you start tracking all of your stuff now and getting it up on GitHub, you'll thank yourself in the future. Next up, backend language. So pick a programming language. If you're not sure which one to go with, I would recommend Python. I say Python because it's fairly easy to learn. Working on web projects is really simple and Python, and Python can do a whole lot of other stuff. stuff. So it's a very good general purpose language. Obviously, there are other languages you can use for this. So you might use JavaScript and TypeScript. That would be fine. But if you're unsure, then I would recommend starting with Python. I have a 6-hour Python video on YouTube as well as a 7-hour part 2. So if you want a little bit of Python material, you can check that out. I also have a Python mastery course, which is going to be a lot more information, and it includes like 9 hours of backend Python material. So that's going to be a lot of applied Python for building backend services. So if you're interested in that course, I will have a link to that down below as well. So the programming language gives you the freedom to do pretty much whatever you want. You can code anything. But if you specifically want to build something like an API or some backend for a website, doing that from scratch could take a lot of work. So because of that, it's often the case that backend frameworks exist, which is really just a software library that other people have invested their time, skill, and energy into to make building web applications a lot easier. So every major programming language is going to have at least one backend framework you could use to start building websites. Some are going to have a lot of options, and you'll have to choose which backend framework to start with. In the case of Python, there are a couple out there. You might have heard of Flask, Django, Fast API, and I would just recommend if you're going to pick one of those, pick Django. Django gives you a ton of features and capabilities out of the box. It's going to help you learn larger scale back-end development, and it will give you conventions and structure so you're not just left with an empty Python file saying good luck. It will give you some starting points on how to structure your projects, and this will help you start to build larger scale back-end systems. Now, if you're going to be working with data, which most likely you are, you're going to want to start familiarizing yourself with databases. The question is, which database do you use? I'm going to recommend you start with Postgres. There are a ton of different databases out there, and they're generally categorized as SQL databases or SQL databases, which are structured in tables, or NoSQL databases, which could be graphs or key value pairs, documents. There's a bunch of different variations for NoSQL databases. Most likely, you can cover all of your needs with Postgres. And if needed, you can have a JSON column, which will allow for semi-structured data where you can vary the values in that data. So Postgres is going to give you the foundation that will work in 99% of cases. It's also open source and free to use for commercial use, so it's a great starting point. And if you learn Postgres, switching to any other structured database is going to be super easy. So do not get caught up on the technology. Same with, for example, the framework or the language. Learning the first and getting really good at it is the most important thing. Then if for some reason you have to switch to something else, you will have a foundation that will make it a lot easier. A lot of the same paradigms are going to be applied, so you might follow particular design patterns or structures. Those are going to also exist in other frameworks and languages. So do not stress, just pick something and get really good at it. Next up, we're going to talk about how do you go from Django to connecting to a database such as Postgres. And this is going to be done in a few different ways. Most likely you're going to start with an ORM. So an ORM is an object relational mapper. And that's going to make it easier to work with a database because you'll just be working with objects in your code. You're not using any SQL, you're just using Python or whatever language that's in, and the library is going to do all of the SQL for you and give you the objects you need. So that's an ORM. You should become familiar with at least one, so the Django ORM is fine. You should also learn raw SQL, so working with the database directly. All of the databases will have different tools for connecting to them. Most likely you can just start by connecting to the database from the terminal. So if you're in Postgres, you can learn a little bit about PSQL. There are also often extensions and softwares you can use to visualize the database. So you can look at pgadmin, and I think Visual Studio Code also has some extensions for Postgres. It's handy to know that raw SQL. If you're limited to just using an ORM, you're going to have a painful time as a backend developer. And I would say this is one of the areas that will distinguish you from a full stack developer. It's often the case that a full stack developer will just know the ORM layer